Hello everyone, welcome to this basic thermodynamic subject. So we are going to discuss about module 1. Subject code is 18ME33. So today we are going to discuss about fundamental concepts and definitions. So in this chapter we are going to study about thermodynamic definition and its scope, and microscopic and macroscopic approaches, and some practical application in engineering thermodynamics. Okay, and the characteristics of a system, boundary and control surface, and its example, and thermodynamic property we are going to study, and their definition and units. So intensive and extensive properties, specific properties, and pressure and specific volume. And what is meant by thermodynamic system, state diagram, path and process, a quasi-static process, and cyclic and non-cyclic process. So further we are going to study about zeroth law of thermodynamics and diathermic wall, and some uh, gas thermometers and temperature measurements. So these are all the things we are going to study in this module. So just I briefed out, and let us discuss about in detail. So what is mean by thermodynamics? So as you know, the word thermodynamics is from Greek word. Thermo means heat and dynamics means motion, heat in motion. So or we have to also call it as the heat. Thermo means heat and dynamics is means of strength or power also. So the thermodynamics is the science of energy transfer and its effects on the physical properties of a substance. Or else also we can define that it is a science of the relations between the heat work and properties of a system. So where we can observe these thermodynamic applications. So even steam and nuclear power plants, AC engines, gas turbine, air conditioning, refrigeration. Okay, so even if you rise in the temperature of the water in the kettle, burn some fuel in the combustion chamber for aero engine for to propel the aircraft. So cool our room on a hot humid day. Heat up our room on cold winter, right? Okay. So some of the coal or gas in a power plant to generate electricity, and petrol in a car engine. So these are all aspect comes under thermodynamics. And now further we are going to discuss about how we are going to approach this thermodynamic subject. So we are going to approach in two way. One is microscopic, another one is macroscopic. So what is mean by microscopic and macroscopic? So the in microscopic approach, what happened? It considered that the system is made up to a very large number of discrete particles known as molecules. These molecules have different velocity and energies. But in case of macroscopic approach, in this approach, the behavior of the individual molecule is not considered, but the studies of the properties of the particular mass of the substance. Means, suppose if a gas we consider, if you heat the gas, and after this heating the gas, the expansion is taking place. So we are not bothered about each molecule of the gas, how much take the pressure and temperature and volume in case of macroscopic. But the whole mass we consider for the expansion of the gas. But in case of the microscopic, each molecule of the gas it is for counted, and we have to analyze for their energy and velocity and volume, etc., or property of a system. So, and quite this kind of approach is very difficult, that is microscopic. So we call it as an statistical approach, and macroscopic approach we also call it as classical approach. So these are all some points related to microscopic and macroscopic. In further, the properties like velocity, momentum and impulse and kinetic energy, which describes the molecules, cannot be easily measured by the instrument. But other side of the microscopic, which describes the system, can be easily measured by the instrument. And in case of macroscopic, the large number of variables is needed to describe such a system. So approach is called complicated. But in case of macroscopic, only few properties are needed to describe the system. This is about microscopic and macroscopic. And for example, for microscopic pressure, temperature, so we can give an example. And this microscopic approach is considered for the molecular motion. Consider example, at a microscopic level the pressure of the gas is not constant, but temperature of the gas is function of a velocity of the molecule. So this most of the microscopic properties cannot be measured with the common instrument or nor can be perceived by the human sense. Okay, let us discuss what is mean by system. In case of thermodynamics, we are going to discuss, we can define a system like it is a study of thermodynamics. We will choose the small part of a universe to which we will apply the law of thermodynamics, or simply we call it as, we will call this as subset of system. Okay, so system is nothing but where our attention is to be focused. Suppose if you take a fan, so if a fan is considered a system and having only we consider only fan as a system, so other than fan we cannot consider as a system, because our attention or focus is on a only fan, working of fan or observation. So even one more example for system is, if a classroom is having a full strength, like 50 students are sitting in a classroom and one faculty will be there, so this is one system. So our attention or focus on to teach the students, so this is our we generally we call it a system. But in case of thermodynamics also, so any particular area if you concentrate or look into it and observe the uh, properties changes or any changes in the property, we call it as system. So this thermodynamic system is analogous to free body diagram, which we will apply law of mechanics like in Newton's law of motion. So this system is microscopically identifiable collection of matter on which we focus on our attention. Example, if you take the water kettle or aircraft engine, that is one kind of system. Okay, this system consists of system, boundary and surroundings. So what is system, boundary and surroundings? Okay, the rest of the universe outside the system, close enough to the system to have some perceptible effect on the system, is called surroundings. So simply we can say that anything is outside the system we call as surrounding, and this system and surrounding are separated by a boundary. This separated boundary are real or sometimes imaginary. So it may be wall or thin layer, whatever. So it is separate the system and surroundings. So again in this system there are three types of system. One is closed system, open system and isolated system. But in case of closed system, what happen, in which there is no mass is going to permit across the system, only always the system is constant mass, but we do permit only heat and work enter or leave, but not the mass. So in the figure you can see only the heat and or work are enter into the system, or heat and work are going out from the system. Here there is no mass is going to be enter or leaving the system. Such a system we call it as closed system. Okay, for closed system we can say it as a piston cylinder arrangement is one of the example for the closed system. Suppose if you take a piston cylinder arrangement that consider having a 1 kg of mass of the gas, and you are giving the heat to the gas, so there is no change in mass, only energy is going to be interacted from system to surrounding and surrounding to system. Such a process, the system we call it as closed system. So next one is open system. Open system is nothing but what? So both energy and mass are going to be interact with the surroundings. So especially the most of the engineering devices are all are open system. In the figure you can identify the system is considering for the receiving the mass, and also it is given out to the mass to the surrounding. Even energy also, energy is nothing but heat and work are entering into the system and leaving out from the system. This is how about the open system. Example is if you take compressor. The compressor is a device where we can increase the pressure from low pressure to high pressure. So here the mass also is entering and out, also leaving from the system. So even energy also is entering and energy also leaving. This is how the open system are going to work. Uh, Next one is isolated system. Isolate means the term itself, isolate means nothing to be enter, nothing to be out. So whatever the system is there, that will be idle or isolate, in which there is no interaction between the system and surroundings of the mass as well as energy. So best example for this one is uh, any the thermal flask if you consider. So if you initially if you take any hot fluid into the thermos flask, after some time the quantity or energy never change, it will not change certain time. So in ideal case we consider as a isolation system. There is no mass or energy interaction between the system and surrounding. Okay students, so we will discuss some other topics in the next video.